All right, we're recording. Good evening, everybody. So, lesson 6, we're in the downward slope. Lesson 7, lesson 8, done, rock and roll. Lesson 8 is like where I show you where to go from here, the intermediate Python, a journey where you can go. And also we talk about the final and we rock that out, right? But right now, we're on a fun lesson. It covers lists, tuples, dictionaries, and some more string type stuff. Um, Lists are exactly what the screen says. It's data structured, it holds an ordered collection of items. The key is ordered. Like if you look at my screen, I define a list here by the square brackets, and I put objects in it separated by a comma. And these objects are made up of strings: apple, mango, carrot, banana. This is indices 0, 1, 2, 3, 0 through 3, 4 items. Kind of makes sense. Um, cool thing about this, relatively easy to define a list. If you wanted to do like my list over here equals, you could just do open close brackets, hit enter, and you do a type on my list, and you see that the class is a list. Can you do a dir on a list? Let's see. And now when you do a dir on a list, you see all the built-in functions that you could perform on that type of object. Yeah, some languages don't, but for the most part, those move into like arrays. But most arrays start with 0, 2. It's just one of these things that 0 is truly the beginning, and as you move away from 0, then it starts to build more objects. It's odd at first, and you could change that. You could change your default indice to 1. I highly suggest never doing that because no one really does it. And when you do it, it causes a riff in some coding or people's level of understanding. But yeah, because you can go negative too, but that's moving into intermediate land. But we'll talk about lists. We'll beat them up pretty good tonight because everything you learned up to this point pretty much works on a list object. And you see they have some cool things: copy, append, clear, count, extend, index, insert, pop, remove, reverse, sort. Reverse is helpful. Sort's very helpful. People give you a list of usernames. They all start with numbers. You can just quickly sort your list. Boom, be done with it. Pretty cool. And you can also create an empty list, not just by calling on open square brackets. You can go like my list two equals list open close parentheses. And now you can also create an empty list this way as well. Sometimes you want to make an empty list because you want to add to it. Adding to it's easy as append, adds to the end, right? And we'll learn that. It's fun stuff. But that's basically how you create two empty lists, the two different ways: open square brackets, call on the list function with open close parentheses, and cool, right? Well, I'm just going to hit F5 on this. We're going to talk about all of this. Boop. Cool. So here we define our variable called shopping lists. We give it a list object, and we just print it out, and here it's printed. Sweet. No problem. Here we create an empty list. We print the empty list. That's exactly what we get, an empty list. We're going to flip over to cheeses now. Cheeses, cheddar, Edam, Gouda, kind of like a Swiss Gouda mix, honestly. Edam is. I had to go out and buy it after I started teaching this because I never had it. And you can start calling on things by index. So you call on your list object, square bracket, the indice you want, and then close square bracket. Here I'm calling on list, indice 1, and then I pull that cheese right out of there. Pretty cool. Pretty helpful. This is a var list range. I missed this one somehow. So this is going back to our for loops using range stop at 3, list, and now it takes that range, it turns into a list of numbers, 0, 1, 2, stop at 3. Pretty helpful. And we're going to work through this and start mixing and matching all this stuff too. The cool thing about a list is that it could be any type of data in each indice. So this one we have a string, a float, an integer, and another list. When we print that, we get it. Where are we at here? Boop, 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 mixed list. And we get our mixed list right there. So it's it's kind of neat because the list itself is an object, right? Which makes sense. Old school making lists, go grocery shop and you pull out a piece of paper. It's a piece of paper. Then you write what you want on it. It itself is an object with objects you want to buy. Kind of makes sense, right? So here we have one of Bill's. Well, now we have a list of lists. So we have one big list with a list and index 0. First one's electric, 50, gas 60, cell 60. And then we start calling on indices. We call on 1, which is this guy. And then we call on 0, which should be gas, right? And that's what we get right there. When you start to move into this list of lists with two values in them, that's usually when I move to dictionary, because a dictionary are key value pairs. It's just a little cleaner to work with, but you'll see that as we move on. But you can do that with a list. Pretty helpful. And here we got cheeses and numbers. We got an empty list, and we say print all 3, and we print all 3. A mutable example. So mutable is a word means that you could mutate things. You could change them. You could alter them. Tuples are immutable. You can't really change the values. Can't change certain things about a tuple, but you can turn a tuple to a list and do whatever you want. Makes sense. We'll talk about that more in detail when we get to tuples. But here we have 17, 123. We say index 1 now equals 5, and then print it, and we change 123 to 5. Helpful when you need to update a list. You just call on the index and pass it a new value. So you're starting to see the functionality of all this, and update list command. I remember that. Yeah, you can do all kinds of wild, fun stuff in this. Now, this gets kind of neat because there's built-in functions that do certain things with lists. So here we have all our integers. We print the numbers, exactly what we do. And then we say length of numbers should have 6. There's 6 objects in our list. Length will give you how many objects are in your list. Max, since they're integers, it knows it's 74 represents the highest max, the value. Min, of course, is 3. And sum works here and gives you the sum. Awesome. Now, if you have a list of mixed objects, or in this case, strings, like cheddar, Edam, and Gouda, length of cheese, no problem. 3 objects. Max, Gouda. It's the Unicode value of the G. And cheese's min is the Unicode value of the C. Now, if I uncomment this and run it, it'll break because you can't sum different strings. It'll fail. It's not a float or an integer, right? No. It's the Unicode value. So this is going back to ard and char, right? So if we go ord of C and hit enter, you get a 67. And if I do a ord of what's the other one that we did? So the dom length max is min max from my Gouda G. What's the G? Get a 71. So these are Unicode values. Python switched from ASCII to Unicode many years ago. When you start looking at ASCII and Unicode, that's a whole different discussion. Just know that modern Python uses Unicode, multi-language, multilingual. It knows a bunch of different symbols, but Python really doesn't know what a G or C is. It has a Unicode value that represents that symbol to humans. And that's the value that we mess with, right? Just like if you do a small c, oops, my bad. You'll see that a small c has a 99 and a capital has a 67. They have different Unicode values, but fun stuff. Ord and char are, there's places and times to use them. Some people use them for the what we just did last chapter, which is that the translator, and it's wrong. because you're not showing me that you understand how to use indices and values and all that fun stuff in strings. You're using other commands that are wrong. Like, it's that simple. Yep, yeah, pretty much. You can think of it that way. And you can always look up like ASCII, ASCII versus Unicode, and it'll explain the differences to you in more detail. But Python strictly uses Unicode unless you bypass that for now. Right. May change in the future, who knows? But that's kind of cool stuff. Here we have a list with all kinds of fun stuff and other lists. Then we get the length of my list, and you see that it's set to 4. Well, 1, 0, 1, 2, 3 is 4. When you do the length of a list with nested lists, it only counts the entire object. It won't go into the sub-object with the length command, right? Just keep that in mind. And now I can do fun stuff with for loops. So now I can say for each piece in cheeses, print piece. So you defined your list, it loads it up here. It says for cheddar, print cheddar, for Edam, print Edam, for Gouda, print Gouda. And that's what we get this. This, I use probably 90% of my code. For each computer in my list of computers, for each IP in my list of IPs, for each exploit in my list of exploits, for each vulnerability in my list of vulnerabilities, for each user account in my list of users, for each password hash in my list of password hashes, you get the gist. You could rip through a list insanely fast, like millions per second. Pretty cool. So any questions on the basics of a list? Because we're going to start running now. Zoop. Cool. So we're still on lists. We didn't move anywhere. Sticking with our cheese, we're saying for each item in our range length of cheeses, print cheeses index times 2. Well, what does that mean? Well, that means for cheddar in my range length of cheeses, so that would be 1, 2, or 0, 1, 2, stop at 3, print cheeses, each cheese, each item times 2. Long-winded way of doing it. You could just literally say for item in cheeses, print cheeses I squared 2. It'll work. But this is just combining nesting functions. So you have your length function that works on cheeses first and gets you the number of 3. So range stop at 3, 0, 1, 2, and then it stops. Helpful, kind of unnecessary. And I mean unnecessary because you should be able to do this. Just get rid of this. Oh, what happened? It broke. Oh yeah, see, list indices must be integers or slices. So now we can't use this indice execution because we didn't grab a number. We're grabbing the object. So there's going to be times where you do need or want to nest your functions to get the number or the index 0. So for 0 in my range, print cheeses index 0 times 2. That's how you get your cheddar cheddar. So there are these little gotchas, but they're really not gotchas if you think about it. If you break down how it really operates, what I just said, it makes total sense. Like it's kind of clean. You can't duplicate an entire range of strings calling on a list location. You have to call on the location, get the object, then multiply that object twice. Once you run through the challenges, you'll get a better feel for it or write some code that does that, right? But it's I'm telling you, I think I use lists, like I said, in 90+% of my code that I ever write because they're just so functional. And usually you're doing with a big group of objects, you're trying to get something done over and over again. And lists are the simplest, easiest object to leverage. So you could get into our addition operators or our concatenators, right? So A, 1, 2, 3, B, 4, 5, 6, A. I say C equals A plus B, print C, and it adds both lists together into one list. It's helpful. Now, what it doesn't do is if you have a duplicate in here, it doesn't remove your duplicates, which you may or may not want. So just keep in mind that there's certain operators that may appear to work on the surface, but they may give you not what exactly you want. And you have to clean up that object before you do something else with it. Remove duplicates, sort it, reverse it, stuff like that. Here we have print 0 times 4. It just prints 4 in a list because we said 0 list 4. We said print 4 of those objects. I've never had to leverage this directly in any code I've written, but it's sort of cool that you could do that. If you need 3 of your lists in order, boop, 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 one list with the same things. It's kind of cool. So if you're doing some type of I don't know, sport and Bob, Doug, and Ann were going in succession, you could be like, okay, we're gonna run 6 heats, Bob, Doug, Ann times 6. Bob, Doug, Ann, but you get the drift, right? Sort of cool. So here we go again. The in operator. Awesome. I cannot tell you how powerful these two little letters are. Here we have our list. We say Gouda in cheeses, we get a true. If your boss gives you a list or something to do and you have 10,000 machines and he goes, hey, is machine Dell GB 1947 in there? You can just go Dell GB 1947 in list, get a true or false back. It's that easy. It's that fast. Um, like I said, millions of comparisons a second. You can find out if something's in a list instantaneously. Super helpful. In is your best friend. Sometimes you want to make sure something is there before you do anything else. That's where in comes in, right? A lot of different use cases. Got some operators. This is like slicing operators. We're basically saying our list start at 1, end at 3, right? So that's what you get. This is much like our last working with strings. Very similar. Start at the beginning, stop at 4, things like that. You beat those up in the challenges. When would you use these? Well, if you pull stuff back from a database and you get an object back from a database, like a tuple or a list, and the first object is the name of the database, you could always start at object 1, like indice 1, right? You don't need 0 because 0 is kind of static. Instead of removing it and altering the original object, you could just start at 1. That's where the slicing comes in handy with lists, right? Things like that. Blah, blah, blah. Here's how to replace stuff, right? 1 through 3. So here's our list. 1, stop at 3, replace with X and Y. That's exactly what we get right there. I often don't replace original data. I'll like copy the list and then I'll damage the copy. Excuse me. I'm telling you, man, this is bogus being sick in the summer. So we're getting into functions of a class, methods. The object that we're working on is lists. I showed you with the dirt earlier, all the functions that a list has available out of the box. And a very strong one is append, add to end. So here's our original list, ABC, call on our list, dot append D, print it. You guessed it, it adds D to the end. Awesome. Extend is a bit different. Extend is almost like adding the two, but it's a bit different. When you have a list and another list, and you say T1 dot extend T2, print T1, you didn't create a third list. You extended your first list with the second. So you added more objects to your list object. That's what extend does. And here's our AE on the end. Sort's pretty cool. Sort is best effort for both integers and for alphabetizing stuff. I never ran into any issues with it. Duplicates, it puts them in order. It'll do AA, stuff like that. A comma A, two separate ones. So yeah, I'll do that too. Add another A in here for fun. So right now the sort, T sort, we do it. You see it sorted A, B, C, D, E. I'm going to save it, hit F5, rerun it. And now with the two A's, it does exactly that. A, B, C, D, E. Now, which indice did it put first? I don't know. I'm guessing the lower indice. What is that? Zero. I'm guessing 4, 5, and that's how it did it. But I don't know, right? I'll have to look that up. Just something to keep in mind. Sort reverse. This is kind of cool. So sort has a parameter that you can set to true, and the parameter's reverse set to true. And when you print it, you get it, it reverses it. Super cool. Now there's also the reverse method. Now this sorted and allowed you to reverse it in one foul swoop. If you just wanted to reverse something and not put it in a specific order, this is when you'd use just reverse, right? So if necessary, if you don't need them sorted, you just need them reversed, that's when you use reverse. Pretty cool. So here we go with pop. Pop. Pop is kind of cool. I always pop an object into another variable though. And that'll make sense right now, right? So T, here's your list, A, B, C, D, E. My list, pop into C2, print my list, print X when I popped. So now we have A, B, D, E. What was an into C2 is now an X. And now we have C by itself outside the list. Very helpful if you need to remove something and just work with that one object, but it does alter your original list. C is no longer in my list. Keep that in mind, right? And remove is a bit different. So you could say remove Tim, the remove method, and it's gone. How do you put it back if possible in the course? Okay, cool. You could simply say append or index and then call on that X and put it back in 2. Not bad. Now, putting it back, this is where I kind of highly suggest copying your original list. Um, and I never damage my original list, so you can always reference it. And if it's a small list, like under 10,000 objects, it's not going to take up much room in memory, right? That's where we're at today, by the way. Like 10,000 is not a lot, which is crazy, right? Um, when you use pop, you usually don't have to put it back because you copied your original list, if that makes sense, right? I'm trying to think of when I ever had to put something back, and I usually don't have to because I usually keep a copy of my original list. And if you pop into C2, you can always call on your original object on into C2 to get that object again if you need it. But I'm trying to think if I ever needed to put something I pop back. Come up short. You can. I mean, it's just something that's not often done when you need to pop something.
Random question, because you said
Yeah,
10,000 is a trivial number at this
yeah.
point in days. How can you query, I guess you query a function to see how fast it is?
Ooh,
That just popped in my head when you said 10,000 was a
yeah.
number.
So there's a couple built-in things into Python that I show you guys in lesson 8 to see how long your commands run.
We'll find
And
out
yeah,
then.
yeah, we will. It's one of those things that it requires its own about 10-minute block of instruction. And you could do it. There's ways to do it that you can see online, like setting timers and counting time start, throw it into a variable, time stop, throw it into a variable, do some math on it to get the length of it. Unnecessary. There's built-in functions in Python that show you that you could set up to monitor everything that you run. Yeah, there's an entire date and time module that you could manipulate too to like get times of how fast it takes to run. But Python has a whole separate library written C under the hood that allows you to monitor the speed of your code. Super cool stuff. We will get to it. I'll show you that in lesson 8.
All right, sounds good.
Yeah, super cool. And that is important. So, along with linting, debugging, knowing, having an average time in your head of on what platform, right? Like that GB10 is a petabyte a millisecond. That's how fast it could process stuff. Um, when you start looking at that types of speeds and that type of data amounts, your mind starts to melt, right? Over the years, they just what we could do with hardware now far surpasses what we could do in the 90s, even early 2000s. Like it doubles all the time, and it's astronomical. Like it takes longer to write something to standard output to the screen to someone to read it than to do all the math and find it on the back end. Like if you were searching for something, I mean, look at Google. Google search engine is powered by AI. It's been powered by AI for over a decade. And when you use it, it searches its database and it's anchored to the web and it pulls all this stuff and it shows you your responses relatively quickly. Well, how did it know that? How did it do that? Well, that's a whole other class. But the way that it does it is string matching, pattern matching, who paid the most for ads, all kinds of fun stuff, right? But if you could do that over the wire and it shows up in your browser in a relatively short amount of time, right? Like, think of that. What you could do locally versus in the cloud or versus the cloud, you have to go through an entire network, multiple hops, get to something, run your mathematics, find what you want, come back through the network, and then display it on your screen. It still happens with under a couple seconds, if that. So the limitations on how fast or how many objects you could parse through really comes down to how complex your objects are, right? Like if each object here was a complete address, like in each list, if this was like someone's name, their apartment number, their street, their zip code, everything in one little between the quotes, that's a complex object, sort of, right? Now, if you get a million of those, it'll take longer than just running through a million ones and zeros, but not much. So that's that where you start to get the intermediate coding, where you start to think of optimization and the limitations of hardware, and you start writing code that is a little bit tailored to your machine or tailored to your outcome as well. So you're on the right track of thinking like this. You got to start somewhere, right? And then when you start at the beginning, you start to realize that there's never an end. It just keeps going. It's kind of cool, actually. But yeah, man, I like that. I like that sidebar. That was a good one. That was really good. I hope that helps. Hope it keeps it interesting. Didn't really answer much.
Oh, it's good.
Yeah. So, so you may be wondering what's the difference between pop, remove, and delete. Well, delete is insane. Remove removes an object, right? But you can see that we still have our original list in T. I removed Tim from the list and stored the list in X and printed the new list. I still have my original list, but now my new list just is missing that object, right? Delete does just that. Delete aborts it, like rips it out. Boom, gone. Gone from memory, never to be seen again. You can't store it in another variable. There's no X equals delete T1. That's what makes it different from remove. Remove allows you to take an object out, store it somewhere else in another memory slot. Delete ganks it out, throws it away. It's gone for good. Big difference. And you can delete whole things here, 0 through 6, print T, and I have an empty list, stuff like that. When you go to print, it doesn't matter. But a list has a bunch of methods. Append, pop, remove, delete. Well, delete's a function. Sort, sort, reverse, reverse. All these fun things you could do with data. That's part of it. Nobody ever talks about this. Well, they do, but data science, machine learning, which usually comes before artificial intelligence and large language models, You have to really clean that data. This is the part where you clean your data. You use all these methods and you polish your data up and you get to where you want, where it's workable. And that's an art form, depending on, of course, the data types you're using and how much time you have, what your purpose is. But pretty cool stuff. Let's see, is this worth it? I don't know. Do, 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 do. Yeah, I don't know. I'll run through this. This is just not really my favorite, and you'll see why. Let's do file, new file. Take a couple things. Pull this over here. So here I just have a characters, a string, spam. I turn it to a list, and I'm going to print it. Good enough. And you see that it takes each letter, puts it in its own object, in its own index in the list in order. Helpful. Sorta? I don't know. Now, if you were to say a for loop for each letter in S, print S, it would do that. If you said for each letter in my list of T, print the letter, it would do that too. It's more of a stylistic thing on what you want to do with the objects, right? Sort of cool. Now, there are some things that are pretty neat, and these are three other things I want to show you. This is the split method, right? So now we take strings and we say my variable of strings, split them, default split with no argument, and you print it. Where are we at here? It splits on the space. So now you could turn a sentence into a list, but you lose your spaces. Maybe helpful if you're looking for keywords or something. And here we say, what's an index to, and we get the back, right? Split is pretty helpful. Now you can also split on delimiters, which is kind of handy. Sometimes databases give you stuff back separated with dashes, semicolons, colons, commas, tildes, all kinds of stuff. And here you can say simply split this object at the dash, give me my object in a list, and there you go. Delimiters, once you know how to split objects with delimiters, if you're working with data that has a delimiter, super awesome. CSV files, comma separated value files, very common in cybersecurity, very common in the world. They're small, they're separated by comma. Split on the comma helps a lot, if that makes sense. Now, join, guess what join does? Join puts stuff back together. Now, we called the delimiter and we said a space. Now we use the delimiter, which is a space. We say join my list. It'll use this object in my variable I defined and then join it and then rebuild my sentence. So if we change this to a tilde, and now everything's joined with a tilde. Join is insanely powerful. Very helpful when you have to take a bunch of data and rebuild it into something, a structure. So split and join are two other more powerful methods that work on lists and strings. Pretty darn awesome. What else we got? Any questions so far? Now nope, cool. I know that you might hate me for this, but this is kind of cool. So last week we were doing all kinds of stuff, deal with the first letter, capitalization, last letter. You could build functions, delete head, delete tail, or define tail, delete head, or whatever you want to do. And here we say delete head, whatever list is 0. Here's my parameter, delete the first object, reprint it. I'll just rip it. So now we say letters, ABC, call on our function of delete head. We give it our list of letters. So T is replaced with letters. We say delete 0, which will remove A when we print it. That's what we get. So you could write yourself functions and always delete the first object if you didn't need it, right? Same thing for the end. Tail, how do you do that? -1. Start at the beginning, go to -1. Define, print tail, reset, boom. We get it, right? Excuse me. Super awesome. So now with these little tools and the methods and slicing with lists, you can start to build functions that could augment your data relatively quickly. Super handy. Now, tuples. We're going to switch over to tuples, right? Tuples look a lot like lists, except they use the tuple command, not the list command, right? And you can define them by wrapping them in parentheses followed by a comma. If you remove that comma, it still works. Did it? Yeah, it did, right? Type 1. String function, print type 1. Yep. No, didn't. Why? Called it a string. Now watch when I add that comma. Now it's a tuple. Wrapping characters in quotes makes it a string. When you use the parentheses and follow it with the ending comma, it'll define that into a tuple. A tuple is an immutable object of objects, a data structure. Very similar to lists. Much of it still works like a list, except when it comes to doing this. So if I do my tuple equals tuple open close, and I do a dir on my tuple, you'll see that it doesn't have all those fun commands like pop, remove. It doesn't have the same methods because it's a different type of object. It's meant to not be tampered with, right? Which is super cool. Very handy. A lot of times when you work with other programs or APIs and you pull back data from something, it gives it to you in a tuple format. It's a very low end, low. It's not, I can't even call it security. It's just the way that it gives you the object through the internet or through the network that it is what it's supposed to be. It wasn't tampered with, which that's a loose interpretation. It's a best effort. But then you could just turn a tuple into a list. Like if you said my list equals list my tuple, and now you do my list, you see that it's now a list, square brackets. Your tuple still exists. My T still exists as a tuple, but I just changed it to a list so I could mess with it, remove things with it, tamper with it, delete, pop, all that fun stuff. Basically the same. I'm not going to dive too much into it. Tuples, you'll get them returned back from certain databases and stuff, um, but not really too much anymore. A lot of it's JSON or that's pretty much it. Haven't we indirectly made tuples, for example? George, print my name is comma. So print is a function that you can't call it a tuple. Um, Print is a function that just takes whatever you put in between the double quotes and puts the standard out. So the screen. And name is just your variable. It's not really a tuple. It's just displaying your objects to standard out, if that makes sense. Yeah, because hello, my name is name doesn't exist anywhere except in the print statement. Those are basically arguments for the print function. So, yeah, cool. Good question, though. So that's all fun. Let's see what we got down here. So let's check this out. Let's comment this out. We'll comment all this. We'll go comment that. I'm using the wrong quotes. I think I'm writing a different language. I use backticks. We'll run this. So we're going to sort some words, right? But 'tis a flesh wound. We're going to grab our text. We're going to split it. So we're going to make a list of words. We did right there. Now we're going to say create an empty list called T. And now we have an empty list. Now we say for word and words, T append the length of word and the word. Okay, so if we look at this, we're going to get but. For but in words, get the length of but, which is 3, and then the word of but, and then append it to my list. So we get 3 but. Cool. So on and so forth, right? Rips through them all. But look at how it puts them in order. Append them for each word, sort reverse equals true. So now we get this reversed order by the first index, index 0 of all the lists. So you could do some cool stuff if you think it's cool, right? Now, when would you want to do this? Cybersecurity URLs for malware. If you want to grab the end of the URI and get how the length of it, because sometimes random lengths for a website are indeed made up, fictitious, and you could do the length of those. If greater than 40, it's probably fake or something like that. You could do some fun stuff there. Um, you're really limited by imagination once you start to work with certain data types and with these tools. Just keep that in mind, right? This is a true to life example right here. This is so say you get malware from somebody and you want to see, you got an email address from the sender and you want to see if the person exists on LinkedIn. So you want the first part. Then you want to see if the company's real or if the domain exists with domain IQ or who is or something. You could separate an email address. You could split it at the at symbol. You could set two variables, username, comma, domain, address split at the at symbol. So Monty will go into the username and the python.org will go into domain. So now you got those. That's super handy, right? If you have a bajillion of these, you could turn this into a program with a couple functions and a for loop, rip through all your spam for the day, see who they target, remove your duplicates, grab all the domains, rip through the domains to see if they're in virus total to see if they're bad domains or not. Pretty cool, right? I think it's cool. You can do all kinds of fun-filled stuff. With Split is super powerful. So now we're going to talk about dictionaries. Dictionaries are key value pairs. What I mean by that is they don't have indices. This is not 1. This is not 0. It's a key value pair that just happens to be first in the dictionary definition. The key is A. The value is 10. That is one object pair, key value pair, separated by comma, next key value pair, next key value pair. Dictionaries are kind of cool. They have their own methods. They have a method called items. And when you rip through this and call on your dictionary, grab your items and throw them in a list and then print your list, now you get a list of your items. Which now I could use all the methods that you know about lists and destroy these things. You could have fun with them, pop stuff, do whatever you want, right? And you can also sort them because you can't really sort a dictionary. It does kind of it doesn't really work out very well. So when you sort your items from a dictionary, no one ever said you couldn't put them back in a dictionary, right? Sorted. But there's something that unique about dictionaries. It really doesn't matter the order they're in if you're using a dictionary because you're calling on a key to get the value or you're calling on a value to get the key. It doesn't matter where it's at. It doesn't matter if it's in order or not. That is something that as you work with more dictionaries and hash tables throughout your career, you'll get used to them not being in order, but just the data being in there. That's okay. Because you can always pull it out and change it to a list, something you could work with, right? Now check this. This is going into the exercises and labs, right? So import random states Key value pair, AL, BAMA. So you have your abbreviation, full name, abbreviation, full name, abbreviation, full name. States, call it on my dictionary. Items, list, random choice. And then I printed an empty line. I didn't print that out though. It's funny. Let's see what this does. Shoop. Here's my random choice now. So now that I printed my random choice, it randomly pulled Alaska from the list it created. Cool. Nesting types of objects and functions to achieve a goal. Doable, right? This last part's pretty important. So we have our dictionary, A10, C, so on and so forth. Now you can use a for loop and define, call them what they are, key, comma, value, in my dictionary dot items. But you want to display them backwards. All you do is call in your variables backwards now since they're in a list format. Items turns them into a list, and you print the value and key. So now you get your dictionary, but backwards. You got your value and your item. Value, key, value, key, value, key. Items in, items and sort are probably your best friends for your lab. If that makes sense. And we're going to beat up dictionaries pretty good. Excuse me again. So now we move to the dictionaries. Dictionary is a list, but more general. What that means is it doesn't have indices, right? No indexes. Cool. But there's key value pairs. Awesome. Here's how you create an empty dictionary. Call the dictionary command, open close parentheses, English to Spanish, now has an empty dictionary in it. Empty dictionary is your curly braces. Cool. Here's how you add keys and values. You call the dictionary name, square bracket, you guessed it, the key equals the value. And that will add your keys and values to a dictionary. That's how you build a dictionary. Pretty cool. Now, when you call on a key value, when you say English to Spanish, I want two, when you call on the key, it gives you the value. And that's what this does right here. We called in the key of two in my dictionary. It goes to your dictionary, calls on two, pulls the value, prints the value. Pretty cool. Sort of helpful. Now, this in stuff is pretty helpful. One in my dictionary, true. In only looks at keys. Uno is indeed a value in the dictionary, but when we say uno in English or Spanish, we get a false because it's a value. In only looks at keys in a dictionary. Kind of important, right? Now we're going to get into methods of a dictionary, which there's quite a few, but we're going to stick with some tried and trues. It has the values. Super helpful. You could say, call your dictionary name, dot values, call the method of values for your dictionary, store them in vals, print your values. So now you have your values in this weird dictionary values object. As I'm showing to you, highlighted on the screen. It's a dictionary's values object. To work with it, you have to turn it to a list. List vals, vals, print vals. And now we have a list of our values, which you can do anything you want with because we already learned how to manipulate lists. Super cool. Now, if you had to do abbreviations to the state name or something, could you create a call in the values, store it in a list, call in the keys, store it in a list, and use in to make sure that it's in there to say yes or no, and then use the indice to match the indice to pull the name back for you. sort of. You can. Now, can you say if you get an answer from somebody like AL, could you say dictionary AL and then get the name back of Alabama? Totally. So just start to think about how you could use these tools to be successful, right? Got your length, only counts key value pairs, gives you two. Min and max only looks at your keys, does not look at values. This is the same. This is kind of fun. This will kind of help you with I think your lab the most. So here we have our key value pairs. There's a keys method. So now you can extract the keys and turn them to a list. And you can get all your keys right here, parrot, cheese, spam. Then you can sort them, do whatever you want, and say for each key in my key list, print the key, call in your dictionary, counts as my dictionary with the value key with the key name, and then what do you get back? The value. So that's a way to pull your values and keys back. It's sort of cool. This is the okay, so here this method is super important. Get. I'm gonna jump down to here. The get method is awesome. So here's a dictionary. You say dictionary, get spam, and it gives you the value. Get is your fourth friend in your lab. Get is awesome. You may not have to create all those lists if you know how to use get and keys and values properly. This is the power of dictionaries, right? I'm not going to go through the brontosaurus thing. It's kind of redundant, but get is awesome. And that's it for this evening. But it's a lot. Like I know it's a lot. I know we introduced three different complex object types. We have lists, tuples, and dictionaries. They each get a little bit more complex. Tuples being the simplest of them all. Lists being the most advantageous. Dictionaries being your key value pairs. You could turn them into lists and manipulate them however you want. Um, but if you think about Excel and data in Excel or comma separated value fields or something, there's so much you could do with just these three object types. You're no longer limited to for each letter in my letter. Now you're for each object in my list of objects, perform these tasks. So for each computer in my list of computers, ping it. If ping true, run nmap on these ports. If port XYZ is open, try this exploit. If exploit works, push reverse shell. Like you can start to build on this logic now. Um, but yeah, that's it. I'm gonna stop the recording for this evening.
Question, if
Yeah,
in Git, if it can't find the key, does it do like a value error?
let's do that. Let's say get. I'll turn this to I'll just say pink. Save F5. You get none.
All right, so it
Very
doesn't
help.
blow up the code, you just get a none.
Yeah, very helpful though, because now I can say if you put this out to a variable, and then you can say like if x equals get pink, and then you can say if x equals none, say not found, else perform this task. See what I'm saying?
Yeah.
So none is pretty helpful. Good question. I'm glad I kept the recording going. Cool. Any more questions? Cool. Go ahead and stop the recording.